All right, so now objective 3, we want to analyze hyperbolas with center at h comma k. If a hyperbola with its center at the origin and its transverse axis coinciding with a coordinate axis is shifted horizontally h units or vertically k units, the result will be a hyperbola with the center at h comma k. So basically just saying that if you have some sort of hyperbola, you're starting with the center and it is coinciding with the x or the y axis, then if you move it horizontally, h units, or vertically k units, your new center will be at h comma k. So now we have this very useful table here. This is telling us the equations of a hyperbola with the center at h comma k, where its transverse axis is parallel to one of the coordinate axes. So our first one that we're going to look at is with our axis parallel to the x-axis. So for our centers at h comma k, that means that our foci parallel to the x-axis will be h plus or minus c comma k. Vertices will be h plus or minus a comma k. Equations will be x minus h squared over a squared minus y minus k squared over b squared is equal to 1, where b squared is equal to c squared minus a squared. And our asymptote now has the new equation of y minus k is equal to plus or minus b over a times x minus h. So our equation for our asymptote is now much more complicated, and now it is really just up for debate on whether it's easier to graph an asymptote or whether it is easier to find those points above and below each foci. Then we also have our hyperbola with its transverse axis parallel to the y-axis. This would give us our foci at h comma k plus or minus c, vertices at h comma k plus or minus a, with equations at y minus k squared all over a squared minus x minus h squared over b squared is equal to 1. B squared is equal to c squared minus a squared, and our asymptote is now y minus k is equal to plus or minus a over b times x minus h. So quite the mouthful there. But we do see that there are significant differences once we move that center. And then we see here in images A and B, we just see the difference with our moved center for our transverse axis being now parallel to the x-axis, and then our transverse axis being parallel to the y-axis. So now we want to find an equation for the hyperbola with the center at 1 comma negative 2, one of the focuses being at 4 comma negative 2, and one vertex being at 3 negative 2. Then we're going to go ahead and graph our equation. So the center is at h comma k, which is equal to 1 comma negative 2. So h is equal to 1 and k is equal to negative 2. So by knowing the center, we were able to determine our values of h and k fairly quickly. Then we see that the center, focus, and vertex all lie on the line y is equal to negative 2. We know this because between the center, the focus, and the vertex, their y values are all going to be negative 2 with different values of x, which means the transverse axis is parallel to the x-axis. So we've determined our center, we've determined where our transverse axis is parallel to. Now we know that the distance, we want to find A, B, and C. The distance from the center, which we know is at 1 comma negative 2. 2, we're going to call this F1, which is at 4 comma negative 2, is C equals 3. Then the distance from center, which is at 1 comma negative 2, to V1, which is at 3 comma negative 2, is going to be A equals 2. So from the center and the focus and the vertex, we were able to determine A and C. So now we have everything we need to solve for B. So we can say then B squared, which we know is going to be equal to C squared minus A squared, is going to end up being 9 minus 4, which is equal to 5. So we get that B is going to be equal to the square root of 5. Then we get that the equation is in the form 8x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Plugging everything that we have in, we're going to get x minus 1 squared over a squared, which is 4, minus y minus k, so it would be y minus negative 2. This is just going to be y plus 2 squared over b squared, which was 5, is equal to 1. So this is our equation. This is what our problem asks us to find. But we also want to graph this equation. And so to graph the equation, we know we either have to find the asymptotes or we have to go ahead and find the points above and below the foci. Since our value of b is going to be the square root of 5 and our asymptotes uses the value of b, let's go ahead and find the points above and below the foci. That's going to be a bit easier for us than trying to find the equation of the asymptotes. So you can say for this problem, the equations of the asymptotes will be difficult to find because of b being equal to the square root of 5. So let's find, we can find the values above and below the foci. We can definitely do that. We can still also find the rectangle that contains the vertices and the specific points. So we can do either one in this case. Let's go ahead and do the rectangle that goes along with finding the asymptote, or finding those asymptotes a bit better than plotting points. So let's find our form. Let's form the rectangle. Containing the vertices. So our vertices are going to be V1 is 3, -2. V2, we know that the distance is going to end up being V1 there, A equals 2. The distance is 2, so that means that since our center is at 1, -2, we go back 2 from 1. This gives us -1, -2. There we go. So our vertex 1 is 3, -2, and vertex 2 is -1, -2. Then we have and the foci, which are going to be at foci 1, or sorry, not the foci. Oops. We use the intercepts instead. So in this case, we're using our intercepts on the axes, which technically, since we've moved the center, they are no longer intercepts. They're just going to be recognized as the points H, K plus or minus B. So these points, which we can just write P1, this will be 1, -2 plus the square root of 5, and P2, which is going to be 1, -2 minus the square root of 5. So we have these points and we have our vertices, so we're going to form this rectangle. The points of our foci, which were not explicitly referenced here, we can find that second foci value. So then is f of 2 is going to end up being -2, -2. All right, so we found values of our foci, our vertices. We have the points on this rectangle that we're drawing out. So let's go ahead and fill these in. So, all right, our center is going to be at 1, -2. So we have our center listed. We have our focus 1 at 4, -2. So this is F1. Our second focus is at -2, -2. This is focus 2. Our vertex 1 is going to be at 3, -2. So this is vertex 1. And we also have that vertex 2 is going to be at -1, -2. So we have these values marked. Now we want to mark 0.1 and 0.2. So 0.1 is actually going to be a value just barely greater than 0. It's going to be about 0.2. So it'll go in right here. This is 0.1. And then our value of 0.2 is going to be just barely less than -4. So it'll be about -4.2. So our point will be about right here, 0.2. And let's actually make these points blue, so now we can draw out our rectangles. So we want to do our best to draw out our lines here. And connect them with our vertices. And now that we want to draw out asymptotes that connect from our center to the corners of our rectangle. So if we go ahead and draw these out, which I will have to move that eventually. Let's move it now, okay. Move that over there. If we draw these out now, we see that our slope is just a little off of -2 and +2. So let's draw these out. They look something like this. And something like this. So rough sketch of our graph. Those are the values that we ended up getting. And now we can draw out our branches. So we have our asymptotes here written out with our rectangle. So our branches are just going to follow along with the asymptotes. And that would end up being our hyperbola. All right. Our last example here, we want to analyze the equation f of x is equal to negative square root of -25 plus x squared. So the format of this problem definitely looks pretty weird, but we're going to break it down. So we have f of x instead of y. Well, f of x is just equal to y. So we can say since f of x is equal to y, we can replace it with y to get y is equal to the negative square root of 25 plus x squared. Did not have to be that big. There we go. So now we have this equation of y is equal to negative square root of 25 plus x squared. The thing we want to notice about this problem now is going to be that y can't be positive, meaning it can't be greater than 0. So we can notice that y can't be positive since the square root of 25 plus x squared will never be negative. Because in order for y to be positive, we would have to have the square root of 25 plus x squared to end up being negative so that the negative signs cancel each other out. So y cannot be positive since the square root of 25 plus x squared will never be negative. Thus y is less than or equal to 0 and is not defined on our graph for positive y values. This means that our graph is really only going to contain half of our hyperbola. So either the bottom part of our hyperbola, so our branch that is going downwards, if we have our hyperbola being its transverse axis either on the x-axis or the y-axis, depending on how it's going to look. Either it's going to look like two branches that were cut in half, or we're just going to see one branch. So we've determined that this graph is not going to be defined for positive y values. It's only going to be defined for negative y values, but let's go ahead and rewrite this in its proper form. So we have that y is equal to negative square root of 25 plus x squared. If we square both sides, this is going to give us y squared is equal to 25 plus x squared, which then we subtract x squared from both sides. We get y squared minus x squared is equal to 25. Equal to 25. I apologize. I realized that I dropped the negative from our original equation. 25 was supposed to be negative, not positive. So I have filled in the negative once again. Everything said previously still holds up. What we see now is that we are left with y squared minus x squared is equal to negative 25, where we definitely don't want our equation to be equaling any negative number. So what we can do is that we can still divide each term by now negative 25, and that ends up giving us negative y squared over 25 plus x squared over 25 is equal to 1. And then we just want to rearrange our equations here to say x squared over 25 minus y squared over 25 is equal to 1. So this is now our equation. And so since we have this equation, we can determine that the center will be at 0, 0, and the transverse axis is along the x-axis. So since it's along the x-axis, this means that our graph is going to look like it's two branches that were cut in half. So instead of looking like just one branch that is basically looks like a parabola, we're now going to have two branches that look like they were just cut off for positive y values. So even though our problem does not require us to define our vertices or foci, asymptotes, anything like that, we still want to write them because we have to graph the equation, so we still want to be able to find them. So then we get that a squared is equal to 25 and b squared is equal to 25. And a is equal to b. As long as we're working with hyperbolas, a being equal to b actually really doesn't make that much of any kind of difference. When we were working with equations of ellipses, we had to have one value greater than the other. We had to have a be greater than b, which was always positive, because that helped us determine which axis was going to coincide with the major axis. In the case of hyperbolas, we don't care which value is greater, a or b, so therefore we don't actually care if they're also equal. This just means that our asymptotes are going to always be x and negative x, or y is equal to x and y is equal to negative x, since they're the same value. They will automatically have those asymptotes. So we have that A is equal to B, which is equal to 5. Then we know that C squared is going to be equal still, squared is still going to be equal to A squared plus B squared, which is equal to 25 plus 25, which is equal to 50, which means that C is equal to the square root of 50, which is actually just going to be 5 times the square root of 2. So we found our values of A and B and C. Then we have vertices at 5, 0, and -5, 0, and foci at negative, or start with 5 square root 2, 0, and -5 square root 2, 0. Then we also know that our y intercepts are non-existent because we don't have any positive values of y, and we have a hyperbola that is going to end up being with its transverse axis along the x-axis. So there are no y-intercepts, but our asymptotes will be at y is equal to, remember, in this case, since it's the x-intercept, the x-axis, the transverse axis is coincides with the x-axis, it'll be plus or minus b over a times x, which, since they're the same values, we get y is equal to x and y is equal to negative x. So we have our asymptotes at those points as well. So now we have all the things that we need to go ahead and actually graph our equation. So let's just highlight some things. We weren't asked to analyze the equations, but it doesn't hurt to identify everything here. So we have the center is at 0, 0. The transverse axis is along the x-axis. We have vertices and foci, and our asymptotes will be at y is equal to x and y is equal to negative x. So going to our graph here, we need to find our center at 0, 0. Our vertices are going to be at -5, 0, and 5, 0. So this will be V1, V2. Our foci are defined at 5 times the square root of 2 and -5 times the square root of 2. That is going to be about a little bit greater than 7 and a little bit less than -7. So we can plot those there. So focus 1, focus 2. And then we have our asymptotes at y is equal to x and y is equal to negative x. So y being equal to x is going to run along this line here. So this is y is equal to x. And this line here is going to be y is equal to negative x. So there are two asymptotes. We have our vertices labeled. Remember, only negative values of y. Y does not exist for positive values. So our vertices will just look like this. And as a note to remind ourselves, y is not defined for positive values. To remind ourselves that we do not draw the rest of our branches above the x-axis in this case. All right. So given an equation that does end up looking like this is how it would end up looking if our equation did have a transverse axis that was parallel or coincides with the y-axis. Then we would see it would essentially just look like a downward facing parabola, because you would just have that bottom branch instead of the halves of the two separate branches. So, all right, that wraps up our section 10.4 today. So I will see you again in section 10.7.